Mr. Abbott here. Time for another boring diagram explanation. This one's number 17. This one has to do with the Earth's rotation, longitude, and time. Now, when I'm dealing with these types of diagrams, I like to introduce a term. You may not have heard of it before, but the term is the Terminator. Okay, when you look at every single one of these diagrams, these models were taken straight off of Regents exams, you'll notice that half of the Earth is light and half of the Earth is dark. The portion of the Earth that's in the light will be experiencing day, and you're getting 180 degrees of daylight. Over here, this part of the Earth is in night. But you'll see that there's clearly a line. I will highlight it right here. This line is separating light from dark. So the name for that line is called the Terminator. So the Terminator is the line that separates light and dark. And there's only two phenomena you could be experiencing. If you are on the Terminator, you're either going to turn into the light or turn into the dark. So when you're at the Terminator, sunrise or sunset will occur. You're going into the light or you're going into the darkness. So to figure out if your Terminator is sunrise or sunset, you have to understand the way the Earth rotates. So I hope you've learned that the Earth rotates 15 degrees per hour. That's the rate of rotation, but it's rotating from west to east. All right, in this model, because we're looking down at the North Pole, all right, this is actually, I would call this a polar view. When you're looking at a polar view, you're going to get 360 degrees of longitude. So in the polar view, you get 24 hours of time. But it's showing you, if you're looking down at the North Pole, the Earth appears to be rotating counterclockwise west to east. This point would be turning into the light, so that would be sunrise. We know the North Pole's on the Terminator, so this happens to be, and they usually give this to you, an equinox. So this would be 6 a.m. This half of the Terminator is going into the light. A point up here would be rotating into the dark, so that part of the Terminator would be 6 p.m. or sunset. Now, every 15 degrees is an hour. So if I divided this, you've got 1, 2, 3, 4 90-degree segments. From 6 a.m., we're turning more into the light. Noon, which is 12 p.m., is always directly underneath the sun's rays, and always directly opposite would be 12 a.m. or midnight. Midnight is halfway through the darkness. So looking at this, if they asked you what time is point X, on this diagram, point X would equal 12 a.m. or it would be midnight. Now, another set of views. This one you're looking at, and it's a side view or an equatorial view. The side view or the equatorial view only gives you 12 hours of time because there's half of the planet that you can't see. Now, looking at both of these models, okay, you can see that the North Pole is on the Terminator, and this sun's ray, the sun's ray where it's hitting directly at a 90-degree angle, called the vertical ray, is on the equator. So we can tell for both of these diagrams, and they usually do this, but both of these represents the equinox. So on the equinox, you get 12 hours of daylight and 12 hours of nighttime. It's spring and fall, okay? It's the days we get equal daylight, equal nighttime. Sunrise is at 6 a.m., sunset is at 6 p.m. Now, for both of these models, they didn't put in the rotation. So west to east is turning like this. Point C is on the Terminator, but it would be turning into the light. So on this one, C is equal to 6 a.m. Each one of these is 2 hours because it's 30 degrees apart. So if you've got 30 degrees between your meridians, that is going to be a 2-hour difference. East is going to be later, so point D would be at 8 a.m. Now, looking at A and B are on the same meridian. Since they're on the same meridian, you should know that they have the same time. I'm going from 60 west to 90 west. I'm going back 30 degrees. So west is earlier, and for A and B, it should be 4 a.m. It's 4 o'clock in the morning, and it's going to take 2 more hours for both of these points to turn and reach the Terminator. Now, the model next to it, slightly bigger, no point on the Terminator, but the Earth is still rotating this way. Okay, if this is 6 a.m. and we still have a 30-degree difference, okay, this would be 8 a.m. for point B, and this would be 4 a.m. Now, this point right here, directly underneath your vertical ray, that would be noon, so that would be 12 p.m., and a point completely opposite, that would be 12 a.m. or midnight. So a side view is going to give you 12 hours of time. All right, back to these models. This time, instead of having the light from the right, this time the sun's rays are coming here. They're giving you noon. This is a polar view. That means we're seeing 24 hours. We're seeing an entire 360 degrees of longitude. If you counted these, you'd see that there are 24 divisions. So each one's an hour. This point right here would be going into the dark. So this time it's 6 p.m. on the bottom of the diagram, and this would be rotating in. You get 6 a.m. here. Now, if noon is facing the sun's midnight, or you should know that's 12 a.m., is opposite. But noon, make sure you know it's 12 p.m. This would be 1, 2, 3, 4 p.m. would be our time at point E. All right, last model. Okay, changing your longitude changes your time. Okay, you get west, the time is earlier, east, the time is later. Now, for this one, they're showing you that the prime meridian is opposite the sun's rays. So this would be 12 a.m., this would be midnight. Right here at 180 would be 12 p.m. A and B are on the same meridian. So when you're looking at this, A and B are going to have the same time. You're going from 180 to 150. So you're doing 30 degrees divided by 15 degrees per hour gives me 2 hours. So if this is 12 p.m., A and B are going to be 2 p.m. in the afternoon. 90 degrees west would be where you're getting sunset, because it would be going from the light into the dark. And 90 degrees east on the top all the points at 90 degrees east would be rotating from the dark into the light, and you would get sunrise. So that's a way to use the illumination of the Earth and how the Earth is rotating to find the time at different longitudes. I hope this helps.